Hi guys, in this video we will discuss about electric current. Again, in this video also we will learn about electric current from the perspective of circuit theory. Charge in motion represent current. In the previous video we have seen that about charge and what is the unit of charge, everything, and here we will define current as charge in motion. When we know that, consider a conductor like this, and when charge is in motion in this conductor, we say that there is a current in the conductor. So when we move charge from one place to another, there may be a chance of moving energy from one place to another. So we have to notice this. We said that electric current is nothing but motion of charges, and when we move the charge, there can be motion of energy. Current in a metallic wire. Normally when we talk about electric circuits, we are talking about the current in metallic wires, and the current in mechanical wires have both numerical value and direction. You have to notice this point. The current in a metallic wire has both numerical value and direction. Let us consider a wire like this, and when we talk about the current through this wire, we normally denote it like this. We will draw one arrow. So this arrow represents the direction of the current, and we will write 4 ampere. That means 4 ampere current is flowing through this conductor in this direction. So when we represent current in a metallic wire, it should have both numerical value and direction. So now we need to notice one important point, that when we talk about current, we are considering the flow of positive charges. We are considering the flow of positive charges. You have to keep this in mind. So when we talk about current flow, we are talking about the flow of positive charges. You may have a confusion. You know that electrons are flowing through the conductors, and why we are considering positive charges in the definition of current. So the reason is that in earlier days people thought that current is due to the flow of positive charges. So they haven't discovered that the flow of current is due to electrons. So they thought that some positive charges is flowing through the conductor, that is why there is a current in the conductor. Later they discovered that the current is due to the flow of electrons. So actually the current is due to the flow of electrons. But when we define current, we are talking about the flow of positive charges. I said that in earlier days people thought that the flow of current is due to the flow of positive charges, and when they discovered electrons, the idea of positive current was so popular and it appeared in many books and literature. So now they can't go back and correct this mistake. So they said that, okay, let us have a convention. When we talk about current flow, we will talk about the flow of positive charges, but actually we know that the current flow is due to the flow of electrons. So that is, see, there is a conductor like this. When I am marking current is flowing, 4 ampere current is flowing in this direction, actually what happens is that electrons are moving in this direction. In a physical conductor, the electrons are moving in this direction, but in textbooks or in our circuits we will draw current in the opposite direction, because we have a convention that the current flow is due to the positive charges. So we have to keep this idea in mind when we study circuit theory. Current is symbolized by the letter I or small letter I. So you have to notice this point. The current is symbolized letter using capital I or small letter I. I will explain why. When the current is constant, we will represent it using I, and when the current is instantaneous or current is changing, we will represent using I of t. So for ease of representation, we will represent it using small letter I. So the current, the letter, English letter which is used to represent current is I. We can write it like small letter I is equal to dq by dt. So that is the instantaneous current. We know that capital Q is used to represent the constant charge and small letter q is used to represent the instantaneous charge. So when we talk about instantaneous current I, that is given by dq by dt. That means the change in charge with respect to time. The change in charge with respect to time. So that is how it is defined. The unit of current is ampere. So we know that different quantities have different units, and the unit of current is ampere. We have already defined 1 ampere in the previous video. That is when 1 coulomb of charge. So consider we have a conductor like this, and this is the cross sectional area of the conductor, and when 1 coulomb of charge is flowing through this cross sectional area in 1 second, then we say that there is 1 ampere current flowing through this conductor. That is how the ampere is defined. So the unit of current is ampere. So it is named after A.M. Ampere, who is a famous French physicist. Now let us check the charge transfer between time t0 and t. So let us consider that there was a conductor and there was a charge at the time of time t0. Let us say q t0 be the charge at time t0 and q of t be the charge at a time t. So what is the difference in charges? So that is dq. That can be considered as a small increment in the charges from the time t0 to t. So it can be expressed as the charge transformed between time t0 and t can be expressed as integral t0 to t I dt dash. That is the integral of the instantaneous current. So in other words, let us consider we have a current like this, a constant current like this. So this is time t0 and this is time t, and this is I and this axis is t. Then when we consider the area under the curve, that is nothing but integration is nothing but considering the area under the curve. This will give the total charge accumulated or transferred from time t0 to t. So that is given by the equation integral q t0. So this is the initial charge to qt, that is the final charge, is equal to I dt dash. So when we talk about the total charge transferred over all the time, which is given by qt, so that is the total charge, I dt dash, this is nothing but dq, so that is small increment, plus qt0, that is the initial charge. So initial charge plus the small increment will give the total charge transferred over all the time. So that is given by qt is equal to integral t0 to t I dt dash plus qt0. So you have to keep these two equations in mind. This equation gives the charge transferred between the time t0 and t, and this is the total charge transferred over all the time. Now current can be of different types. So we can see current which is a constant throughout time, so that is known as direct current. And there can be current which is varying. This y-axis is I and x-axis is t. You can see that the current is varying sinusoidally with respect to time. So this kind of current is known as sinusoidal current. And we can see that here a current which is decreasing exponentially with respect to time, and that kind of current is known as exponential current. So current can be of different, we can have different mathematical models for the current. Here the current is constant, here it is sinusoidally varying, and here it is exponentially decreasing. The current is not restricted to these three, it can have any shape. So it can be a randomly varying current like this. So it can be of any type. As I said, the current is represented by an arrow near the conductor, and we will also write the value, how much current is flowing through the conductor. And if we don't know the value of current flowing, then we will draw the arrow and we will write I. Some current I is flowing through the conductor. So that is all about electric current when we look from the perspective of circuit theory. So I hope this is clear. Thank you for watching.